Hey guys, just wanted to post a video that can hopefully help you out with homework for one through 3, the review section that we're doing right now. It's 1 through 3.2 is the homework problem. You might recognize it just from looking over here. So first, before we get to the mathematical portion of it, let's just look at this problem, the way it's set up, and get our bearings on how we're going to handle this. This is a pretty common problem, or common setup at least, for what we've been doing, where we have a few different forces and we're given a little bit of information about each of them, and then we have to solve, and it ends up basically being multiple equations with multiple unknowns. So in this case, it's going to be 2 equations and 2 unknowns, and we have to solve for those 2 unknowns. So we have to solve the system of equations. So let's kind of just verbally figure out what the different equations we've got here are. We'll start by summing our forces in the y. Let's do that first because it's nice, because you notice that this resultant force is along the x-axis, and what that means is that the force in the y that's positive has to equal the force in the y that's negative, because if it didn't, then this force resultant would be up at an angle. It wouldn't lie along the x-axis. And I hope that makes sense, because if the force was imbalanced in the positive y direction, Fr would have some positive angle relative to the x-axis, and if it was imbalanced in the negative y direction, then Fr would have some negative angle relative to the x direction. So the fact that it doesn't tells us that the y direction, the sum of the forces in the y direction, is equal to 0. So I can know that whatever component of Fa is going in the positive y direction is exactly equal to whatever component of Fb is going in the negative y direction. So now I know that I can set up my equation to be 0 equals, and now I need to figure out what the y component of Fa is, and that would be cosine of theta, and the y component of Fb would be sine of phi, if that makes sense. So that's my y equation. Then my x equation is going to be some positive number, and lucky for us, they give us Fr, which we know is all in the x direction. It's all in the positive x, so that makes Fr a little bit simpler. And we'll just go over that over here as we get into the Mathematica. So with Mathematica, if you've been using it and trying to figure it out this semester, one thing that you may have noticed is that solving systems of multiple equations is pretty easy and straightforward, as long as you don't involve trig functions. It's easy to solve single functions that have trig in them, but as soon as you involve multiple equations that have trig functions in them, it gets a little bit more complicated. And the reason for that is that trig functions are periodic, which is what we're going to talk about. You may have noticed that it gives you some kind of funny answers if you do that. And to be honest, I struggled with this. I was having a hard time remembering how to do this, and so I went to a professor who I had when I was at BYU Idaho, named Dave Johnson, and he actually still teaches at BYU Idaho. He's a great professor, and if you ever have any questions about Mathematica and you're on campus and he's available, by all means, go talk to Brother Johnson. He is great. He is very good at explaining it too. So just a shout out to him for helping us out. But let's start with an example to understand how to use solve and these expressions in Mathematica. So if I have solve here, and I'm trying to solve a trig function cotangent of some angle c, and I have it set equal to some value s, then I tell it that I want to solve for c. That's the basic setup of the solve function. I say solve, square bracket, then whatever my function is, double equal sign. Always remember that. If you put a single equal sign, it's not going to work. And then I set it equal to whatever it's equal to, and then comma, and then whatever I want it to solve for. Then close bracket, it's going to give me an answer. So in this case, obviously, I've just got one equation, but I have 2 unknowns, so it's going to give me a symbolic answer, because it doesn't know how to solve, and as far as I know, no one does know how to solve an equation with 2 unknowns, one equation with 2 unknowns. So what we've got here is it says C is a conditional expression. It says it depends. It depends on what S and C are. But if you're solving for C, then it says you're going to have arc cotangent of S, which if you remember is how you'd solve that, plus pi times some random arbitrary constant C. C1 is what we call that. And it says where, that's what this comma says, where C1 belongs to this symbol, the integers. So in saying as long as it's an integer, as long as C1 is an integer, then your answer, C is going to be arc cotangent of whatever S is plus pi times your arbitrary constant. So you could stick in anything you wanted into C, and that would allow you to solve. But, so it's a periodic function. That's what that means, is that every so often it's going to be the same thing if you do that. And that makes sense if you think about the trig functions. If you think about how in algebra or calculus, when you plot those trig functions like sine, there's a sine wave, right? It goes up and down and up and down, and it's periodic. It periodically is equal to the same thing. So if you want to simplify that, because we are simple engineers and we don't like things that are complicated like that, then there's a way to do that here in Mathematica, and that's with what Brother Johnson explains is called a rule. So you can say solve of whatever that is, and then do / period C1, which is your arbitrary constant, and then this arrow symbol, and then what you want it to be. And in this case, we want it to be 0 because we want to simplify it. Because it can be arbitrary, it can be anything, right? As long as it's an integer. 0 is an integer, and it's a good integer because it makes things simpler. So, and just to note, this arrow symbol, the way you write that in Mathematica is a dash, like next to your 0 on your keyboard, that dash, and then the right or the greater than symbol, so shift period. And then if I hit enter, that would be the arrow symbol there. So if I do that here, then that gives me C is equal to just arc cotangent of S. So you notice we got rid of all this because, up here. We got rid of all this because 0 times pi is 0. So it's just arc cotangent of S. So after that long explanation, let's try actually doing this with our problem over here. We know that FR, according to Maple TA, is 1200. We know that FB is equal to 650. We know that phi, and the way you get phi like that, if you do escape, and then capital PHI, escape, no, that's capitalized. We want lowercase phi, then you get it that way. So escape, phi, escape gives you the symbol. But if I just want, you can type it or whatever you want to do. And then I'll type solve, square bracket, and then when I have multiple equations, I have to enclose them in curly brackets like that. You'll notice that I have an open and close curly brace, and then I have my first equation, and then I have a comma to separate the equations, and then I have my second equation, and then I close the equations section. And then the comma tells Mathematica that the next thing I'm going to tell you is what I want you to solve for, in this case, that's multiple things, so I'll enclose them in curly brackets, and it's FA and theta. So we type that in, then we close the whole thing off with a square bracket, and then to get it to simplify for us, instead of giving us nasty symbolic answers, we say / capital N, hit Control or Shift Enter to get it to evaluate, and it gives us, surprise, surprise, a conditional expression answer. It says it could be either FA is equal to -983 and theta is equal to 57.2 times -2 plus 6.2 times some arbitrary constant C when C belongs to, if I hover over this, Z, this kind of funky double bar Z, the integers. Well, we know that it's not a negative answer, so let's look at the next option that it gives us. And in this case, it's negative 983.7, or rounded up, hey, that's 984. That's good. That's the right answer. And theta, the angle, because this is a trig function and it's periodic, is a conditional expression. It's 57.3 times, we'll call it 1, plus 6.3 times some arbitrary constant c, where c belongs to the integers. So we know we've got the FA correct, and that's good, but we really want to get it to simplify and be nice to us, so we're going to use that rule expression that Brother Johnson taught us about, and we'll re-enter everything, and down here at the end of our solve function, instead of just doing /n, first we'll put / c square bracket 1 square bracket, and then remember how we enter this symbol is dash, and then greater than symbol, and then we go to the end of the line and hit shift enter, and voila, we get FA, and we know it's the second one because we don't want a negative answer, is equal to 984 rounded, and theta is 57.2. And hey, look at that. That's the answer. So now you know the secret. Go have lots of fun solving systems of multiple equations with Mathematica.